All right, we are going to look at 3 special angles. Okay, these are things you're not going to have to rederive them, but you're going to have to know what the cosine and sine of these special angles are. So the first is 45 degrees. So here we've got initial side, terminal side, our angle intersects the unit circle here at x, y. And this angle is 45 degrees, or in radians, that would be pi fourths, right? This is a quarter of like this would be pi halves, this is half of that. So this is pi fourths. All right, so we want to know what the x and y values are, what the sine and cosine of this triangle are. So let's think about some things we know about this triangle. If it's a right triangle, and if this angle is 45, we know that this angle is also 45, right? Because triangles have to add up to 180. So this is an isosceles right triangle. That tells us that these two sides have the same length, right? So whatever sine is and whatever cosine is, they're going to be the same value. And we also know that the hypotenuse of this right triangle is 1, since this is the unit circle. So that's pretty handy. This is kind of just another showing you in the whole unit circle what we're talking about here. So we know that y equals x. So how can we go about solving this? We could use the Pythagorean theorem, right? Or the Pythagorean identity. X squared plus y squared equals 1, right? And we also know that x squared and y squared are equal. So x squared plus x squared equals 1, 2x squared equals 1. We can say x squared equals 1/2. X is going to equal plus or minus 1 over the square root of 2. If we take the square root of the right side of that equation, and we are taking the square root, so we have to say plus or minus. Well, you tell me, are the x and y values positive or negative? Well, they're positive, right? This is along in the quadrant 1. This is along the positive x direction and the positive y direction. So we're going to take the positive of that. So cosine is 1 over square root of 2. Sine t is 1 over square root of 2. And hopefully this bothers you just a little bit. Remember, we don't like to have radicals in the denominator. So we need to rationalize that denominator. Ooh, and my picture is covering it up. Can I move it? Oh, I can. There we go. So we multiply numerator and denominator by square root of 2 over 2. We get square root of 2 over 2. And we can do the same thing for sine. So both the cosine and the sine have the same value, which is what we expected. It's square root of 2 over 2. All right, so this is square root of 2 over 2. This is square root of 2 over 2. We're going to come back to that, and that's something you're going to have to know. Okay, sine of pi fourths, cosine of pi fourths is square root of 2 over 2. All right, so now let's talk about 30-degree angle. All right, we're going to be a little bit clever here, and we're going to say, okay, well, here's our 30-degree angle. Incidentally, if this is 30 degrees, what's this angle? 60 degrees, right? Because they have to equal 180. And we're going to make two. So we have a 30, 60, 90 triangle here, and we're going to make another 30, 60, 90 triangle, okay, that we're going to just kind of stick below it. So now tell me about this triangle. What's this whole angle together? 30 plus 30 is 60. This is 60, this is 60, this is 60. It's an equilateral triangle. All these sides are equal. Cool. And tell me, what is this? How long is this radius? It's 1, because this is a unit circle, right? So we've got an equilateral triangle. All the sides are 1, but we kind of already knew that. What we're interested in is this side and this side specifically, right? We want to know what cosine of 30 degrees and sine of 30 degrees are. Okay, but this is very helpful information. If this side is 1, this side is 1, and that means this side is 1/2. So we're going to talk about this as pi 6 now. So sine of pi 6, this is 1/2 of that radius, right? But since our radius is 1, sine, this is here, is 1/2. Right? Okay, well, terrific. If we know we have a right triangle and we know one side, we can definitely find the other. Let's use the Pythagorean theorem. Cosine squared of this angle plus sine squared of this angle. So this side squared plus this side squared equals 1 because we have the unit circle. We don't know what cosine is, but we do know that sine is 1/2. So we multiply that, we get 1/4. We subtract it, we get 3/4. So cosine squared of pi 6 is 3/4. So we take the square root of both sides. We get square root of 3 over 2, plus or minus square root of 3 over 2. And tell me, is this x value positive or negative? It's positive, right? Since it's along the positive x direction. So we take the positive value. So sine of pi 6 is 1/2. This is 1/2. This is pi 6. Or this is a square root of 3 over 2. Cool. So we found the sine and the cosine of this angle 30 degrees. That's our second special angle. Here's our third special angle. All right, ignore this second triangle here. Your book derives it in a certain way. I think it's really confusing. What we've got here, just look at this main red triangle here. If this angle is 60 degrees, this is 90, this is 30, right? This is just the same triangle turned a little bit, right? We just did this. We just figured out back here, if we have a 30-60 triangle, 30-60-90 triangle, this side, the short side is 1/2, the long side is square root of 3 over 2, right? Well, now that's just switched. This is the short side, this is 1/2, and this is square root of 3 over 2. We don't have to rederive anything, right? We've just turned that triangle up, right? So maybe go back and think about that for a minute if that doesn't make sense to you. But the cosine, this short side is 1/2. The sine, the y value, is square root of 3 over 2. That's our third special angle. Said we're going to do 3. That's our third. All right, so here's the summary. Okay, 30 degrees, 45 degrees, 60 degrees. Okay. For 45 degrees, remember it was square root of 2 over 2 for both of them. For 30, it's square root of 3 over 2, 1/2. For 60 degrees, it's switched. This is 1/2, this is square root of 3 over 2. And here this is in a table. You are going to have to memorize this table. We will use these all semester, and if you do not memorize these few things, you're going to be sorry because there's going to be tons of questions you just can't do. You have to know these values, okay? So we'll talk about that more in class, how we're going to do it, but hopefully it makes, so like I said, you're not going to have to rederive them, but hopefully it makes sense where these came from. It's only 3, and look, these are the same. They're just flipped, and these are the same. So really there's like 3 values you have to remember. You can do it. Seems like a lot at first, okay? But you can do this. All right, so we're going to use these. We'll come back to this, but that's an introduction to that. Now let's just talk about this for a minute, using a graphing calculator to find sine and cosine, right? What if we want to evaluate cosine of 5 pi thirds? So let's look at this, and hopefully I can make it a little bit bigger. All right, so here's my calculator. I'm going to turn it on. All right, so how can we evaluate this? I'm just going to say cosine of 5 pi divided by 3, cosine of 5 pi thirds. Oops, I got an extra parentheses in there. That's okay. I get 0.9958. What do you think? Does that make sense? Let's just think for a minute. 5 pi thirds, where's that angle going to be? Well, 5 pi thirds is more than pi, right? So it's going to be more than this. It's going to be almost 6 pi. I mean, it's almost 6 pi thirds, almost 2 pi, right? So that's actually going to be in quadrant 4. Maybe think about that for just a minute and sketch it real quick. Does it make sense that x value for that is 0.995, like almost 1? Not really, right? What happened here? This is the tricky thing. You've got to, when you're using calculator, don't let it trick you. Look what happens. If I go to mode, it's in degree mode. Dun, dun, dun. Okay, this is the bane of trig students. Okay, you got to make sure if you're dealing with radians, it's in radian mode. If you're dealing with degrees, it's in degree mode. Okay, so now what if I do the same thing? Now we're in degree, 1/2. That makes a lot more sense. I would believe that. right? Okay, so that's how you switch between degree and radian mode. And always kind of do like a quick mental check to make sure that what you get, if you're using your calculator, makes sense.